Okay, so question says to give the full electron configuration of rubidium in the ground state, provide the orbital diagram of the last subshell with electrons. Provide the quantum numbers for the last electron. Okay, so first let's write out the electron configuration of a rubidium atom in ground state. So first we need to divide our periodic table into the different sections. Of the orbital shells. So this column is the S block, and this green is the P block, and the middle is the D block, which are the transition metals, and lastly the last two rows is the F block. So starting from hydrogen, we're going to move left to right across the periodic table, writing the row number and then the block letter. But when we get to the D block and the F block, or the D block, the number is going to be the row number -1, and in the F block, it's going to be the row number -2. Okay, so let me write out an example. So for rubidium, rubidium is found here, atomic number 44. So starting from hydrogen, we write 1s2, and then to the next row it is 2s2, and then moving over to the P block is 2p6, and then continuing on we have 3s2, 3p6, and then once we get to the fourth row, the D block has a lower energy than our S block. So we're just going to write our D block before we write our S block. So this makes it 3d10, and then 4s2, and then 4p6, and then 5s1. So this is the ground state electron configuration for the rubidium atom. So the second part of the question says to provide the orbital diagram of only the last subshell with electrons. So our last subshell is the 5s subshell. So let's write our orbital diagram box, and I'll label this as the 5s subshell. And there's only one electron, so I'm just going to draw a single electron pointing up. And now we just need to provide the quantum numbers for this last electron. So since it is in like row 5, our principal quantum number, which is n, will be equal to 5. And our L value is based on the block letter. So for example, if you're in the S block, your L value is 0, the P block is 1, the D block is 2, and the F block is 3. So I'll just keep this up. So since we're in the S block, then our L value would then be 0. And because our L value is 0, our ML value can only be 0 as well. And for the magnetic spin number, since the electron is spinning upwards, we're going to write +½ If it was spinning down, then it would be negative half. Okay, so this is 3A. So now let's see part B, which is to give the full electron configuration of a zinc 2+ ion. Provide the orbital diagram of the last subshell with electrons, and then provide the quantum numbers for the last electron. So it's a similar question to the first, but instead we deal with the cation, zinc. So it had a 2+ charge. Oops. It had a 2+ charge, but first we're going to write the electron configuration of a zinc atom in its ground state. So it's the same process. Zinc is found right here, atomic number 30. And let's start to write down its electron configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d10 I'll write first. And then I'm going to write 4s2. Okay, so now if we have a zinc that has a 2+ charge, this means that 2 electrons were removed. So the electrons that are going to be removed are the ones from this 4s subshell. So now we can write our new electron configuration. It's just going to be the same thing, except it's going to be missing the last 2 electrons. Okay, so now we're going to draw the orbital diagram for the last subshell. So in this case, it is the 3D subshell. So now let me draw out the boxes. So the D subshell is able to hold 5 electrons. 10 electrons, sorry. And these numbers range from -2 to +2. And if we had 10 electrons, then the whole thing would be filled. So let me show how one would fill in the electrons. We have them all spinning up first, and then when we start to fill in the rest is when we would spin down. Okay, so this is our filled 3D subshell. And now let's write out the different quantum numbers. Okay, so since we're in the 3D subshell, our n value is equal to 3. Our L value, according to the table that I wrote out, will be equal to 2. And then for the last electron, our ML would then be equal to +2. So we're talking about this electron right here. And since it is spinning down, then our MS value would be -half. Okay, so now let's look at part C. Circle the orbital diagram that has the correct arrangement of electrons in the orbitals. What kind of subshell is this? So they have different options. So looking at the first one, everything is spinning up, even the second electrons that were written So the first option is wrong. And the second option, they started to fill in electrons going down, even though the whole subshell wasn't filled with electrons spinning up yet. So the second option's wrong. And the third option, everything is filled except for one of the first boxes. It doesn't have an electron spinning down, so that's why this one is incorrect as well. And our fourth option is actually the correct one. We can double check this because our last option has two filled boxes with the whole subshell, the rest of the subshell being empty. So we know that the fourth option is correct. Fourth option. The one where they filled it in correctly, so you can show the electrons spinning up. And then for the last two is when you would start to fill in the electrons going down. So the type of subshell is a 3D subshell, or just a D subshell in general. Similar to our example in the previous part of the question. So now let's see what the junior tutor said. Rubidium is in group 1, period 5, therefore it has one valence electron in the 5s orbital. So the full electron configuration of rubidium is the following. Yep, so that's correct. And then they drew their diagram. N is equal 5 because it's in energy level 5. L is equal to 0 because it's in an s orbital. ML is equal to 0 because the s orbital can only have one orbital. And ms is equal to plus half. The electron has an upspin. Yep. And for zinc is in group 12, a transition metal in period 4. So a neutral zinc atom will have the electron configuration. So this is the short form, which is good as well. Argon 4s2 3d10. The neutral zinc atom loses 2 electrons from the 4s orbital. So the zinc 2 plus ion has the full electron configuration of the following. Yep, so that's correct. And then they wrote out their 3D subshell. N is equal to 3, L is equal to 2, ML is equal to 2, and MS is equal to negative half because it's spinning down. And then lastly, option 4, which is D, a D subshell. All d orbitals have to be occupied first before electrons pair up. Paired up electrons must have opposite spins. Yep, so that's a good summary of the rules. So this solution is correct.